For this is your cover lesson for Monday, 25th of February. It should be period 6, and hopefully you're all listening to this. So to get you started, this is your starter to go. So have a go at it for 5 or 6 minutes. It's a pretty tough one. The height of this giraffe is 2.5 meters plus half of its height. How tall is the giraffe? Have a go. I'll pause the video and I will come back when you're ready to start it again, okay? About 5 minutes tick. Okay, so let's see if anybody got the answer. Easiest way to kind of think of this is the height of the giraffe. So let's call the height of the giraffe h. Is 2.5 meters plus half of its height, which we said is h. So the height is 2.5 meters plus half of its height. If we can work out what h is, we can work out what the height of the giraffe is, okay? Because we're saying h is the height. The height of the giraffe is 2.5 meters plus half of its height. Now, if you want to pause the video and go back and try and figure it out, go for it, okay? But again, don't spend too long. We do have other stuff to do. So we've got 2.5 plus, now of in maths means to multiply. So I've got half of the height. Now in order to find out h, what I'm going to do is I'm going to subtract, let's use a different color. Subtract a half h from both sides. And when I do that, what's h take away half h? H take away a half h, well that just leaves me with half h. And on this side I'm left with 2.5. Now in order to find out what h is, I need to divide both sides by a half. So I'm going to divide this side by a half, and I'm going to divide this side by a half. And it's frozen. So I'll take this up here. So the height is equal to 3.5 divided by a half. Hopefully you'll remember, if you're dividing by a fraction, you change and flip. 2.5 times 2, remember this is still over 1. 2.5 times 2 is 5. So the height is equal to 5. Did anybody get it? Let's just check its height. Let's use a different color to check. The height is 2.5 plus half of its height. Now if we're saying if its height is 5, half of its height, half of 5. Half of 5 is 2.5. 2.5 plus 2.5 is 5, which is the height. Okay, hopefully you all got that. Okay, so we're going to go on and look at our graphs of y equals sine ax and y equals cos ax. Going back to these ones, which you did well, we were looking at what happened when we had a number in front of sine x or sine theta, okay? And we determined that this number in front of the trig function was the amplitude, okay? It told us how high our sine curve went, or our cos curve. So when we come back to this one, we want to figure out what does this 2 do, okay? Now, I want you to, I've got this sheet for you, okay? It will be given out, and I want you to complete the values in the table, okay, in order to be able to draw y is equal to sine 2x. So just to kind of go through, we're saying that x is are these values. You have to work out 2x first. So that means you're just doubling each of these. 2 times 120 is 240. and then you're working out sine of these values, okay, and writing them in. Then you're going to plot this value against this one, okay, and you're going to do that on this piece of paper, which is also given out to you, and you're going to draw a nice smooth curve, okay? When you've got that, I want you to write down what the amplitude is, and then also what the period is for sine of 2x. Okay, now if you get that done, which you should, I want you to do the exact same thing for cos of 2x. And I've just noticed a mistake in here. Can anybody spot it? Let's just change it up. We should all know that cos of 2 times 0, cos of 0 is 1. Cos of 60 degrees, cos of 60 degrees is 1/2. So this value in here should be 1/2. Okay, so continue filling out this table, and then you're going to draw it as well on another one of these sheets, okay, which will be given out. And then answer the questions. What's the amplitude? My goodness, let's change this. We want the amplitude of cos 2x, and what is the period of cos of 2x, okay? Now, if you get that done, I want you to check these, okay? So go on to Desmos. Okay, so just desmos.com, calculator, and put in certain values. So y equals, let's put in y equals sine x. Okay, now it might look a bit funky. If it does look like this, it's not incorrect. You just need to go up to the little home. Sorry, apologies. You need to go up to the graph settings, and we want to make sure it's in degrees. Okay, we want to go on our x-axis from 0 up to 360. Okay, so now it looks more familiar. And we'll change our y-axis from -2 up to 2. Okay, and it should look even better. Okay, and we want to figure out what happens if we have, let's say, sine of 2x. Okay, but again, draw it first, and then check it on Desmos after. Okay. Now, if you get all of that done, I want you to have a go at the following. I want you to draw y equals sine 3x, part B, y equals cos of 4x, and I want you to answer the following question. What does the number in front of the x tell us about the period of the graph? Okay. Okay, so I've just typed that up there to make it a bit neater so you can see it. I'll just get rid of this bit. Don't need that anymore. Okay, I can delete. Okay, we don't need any of this stuff. All right, so I have fixed the numbers in the table here, okay, so that should be fine, and I have also typed that up as well, okay, to make it a bit neater. So I'll print this off, and you can have a copy of it. So just to clarify, you're going to draw sine 2x, you're going to complete the table, draw sine 2x, answer the questions. You're going to complete the table, draw cos 2x, answer the questions, these two questions. You're going to check your diagrams on Desmos. Then you're going to draw sine 3x and cos of 4x. Okay, you do these on separate pieces of paper. And then you're going to answer, what does the number in front of the x, so this number, tell us about the period of the graph, okay? And that should take the whole period, okay? Now, if you manage to finish all of that, then you can go to the online textbook, which is on Manage Pack, and go to page 539, and have a go at question 2 and 3, okay? That should take you quite a bit of time drawing those, getting them neat, and checking them on Desmos and answering these questions, okay? You could also have a go at question 4 on the next page as well, if you get those done. Okay, so good luck with that, and if you've got any questions, feel free to drop me an email.